The question is not, what's the model? The question is not, what is Toyota doing? The question is, how do we transition to what the model depicts? Whatever model you want to follow. It doesn't matter if you follow this one or a different scientific thinking model. They're all pretty similar. How do you make that real? How do you get your mindset to function that way? How do you get your behavior to function that way? That's what this conference is about. One answer to that question, just one answer, is that you take this practical model, scientific thinking pattern, you take some kind of pattern, like the 4 steps of the Improvement Kata or a similar scientific thinking pattern, and you combine it with daily routines of deliberate practice. And if you bring those two together, they're not new. Scientific thinking is not new. Deliberate practice is not new. It's been around for centuries. And if you do sports or music, you know all about deliberate practice. But bringing those two together is somewhat unique. And in particular, what we're about here is making scientific thinking something anyone can do. It's not complicated. It's not difficult. It's just not our natural way of thinking. I grew up thinking scientific thinking is something for professional scientists who wear white smocks. It's not true. And if you meet the best scientists, they say, oh, no, there's nothing special about what we do. We've just practiced this routine. We just have a certain way of approaching goals or problems. So let me talk about those two factors briefly. Number one, scientific thinking or a practical scientific thinking pattern. You should have this card in your pack. If you would grab it, take it out. Turn the card to the side that doesn't have the line, like the one on the screen. Okay? And let's follow the instructions. Okay, hold the card in front of you with the dot on the left-hand side. Close your left eye and stare at the dot with your right eye, and then move the card back and forth. So you're staring at the dot. What happens? The cross disappears. Why does that happen? Why does the cross disappear? It's your blind spot, meaning that's where the wire is attached to the back of your eye and there are no photoreceptors there, right? So you can't actually see that particular spot. Flip the card over, please. Let's do the same thing. Put the dot on the left. Hold the card in front of you. Close your left eye, stare at the dot with your right eye, and move the card in and out. And try to find that spot again where the cross disappears. What happens this time? Go ahead. Just the vertical line disappears. You see that? The horizontal line stays contiguous. But we know for a fact we can't see a part of that line. Why didn't the brain say, put a hole in it right there? Why didn't it put a gap in it? Because you can't see it. We can't actually see it. Why didn't the brain say, I'm not sure if that line continues or not. I need more information. Go conduct some experiments. You know, what did our brain do instead? It assumes the line continues even though you can't see that part. And that's interesting. So the brain doesn't necessarily show you unfiltered reality. The brain takes patterns. The brain takes things that you've experienced in the past. The brain takes assumptions that we have, and it fills in the blanks. Our brain creates feelings of certainty based on the bits of information it receives. It jumps to conclusions, right? Quickly and unconsciously fills in the blanks. So we don't notice what we call the knowledge threshold. That's a term we use in the Kata community. There's a knowledge threshold. There's always a knowledge threshold. But we don't see it and we shoot over it because our brain fills in the blanks. Now, that sounds like I'm being pretty critical about this jumping to conclusions nature of our brain, right? But the fact is, we need that mechanism to get us through the day, right? Our survival depends on it. Just imagine if you were going through the day and every time your brain wasn't quite sure. The blind spot is just one example of something you're not sure of. There are many, many things we're not sure of. Just imagine going through the day, and every time your brain is not sure, it would say, hold on, I'm not sure. That car could be coming into your lane, but don't worry about it just yet. We wouldn't make it through the day. So it's faster. Our brain uses a lot of energy, and if you had to stop and think about everything, you couldn't, remember when you learned how to drive a car? You couldn't look out the windshield because you were looking for the brake pedal, right? Your brain was busy. Your brain can only handle, it's called cognitive resources. We only have so many cognitive resources, so much capacity. So it really prefers to jump to conclusions and make quick decisions because it keeps our brain capacity open for dealing with things that we do need to concentrate on. And it's a kind of a better safe than sorry approach, right? Maybe that car isn't coming in my lane, but I think I'm going to swerve out of the way just in case because my brain is reacting there. And it's an adult thing. children don't have so many neural paths in their head yet. They're exploring. They function sort of like scientists in many ways. They explore the world. But the trade-off is a child can't drive a car. If you put a child on a sidewalk in a city, that's not going to be good. They can't maneuver life yet because they don't have neural pathways that tell them how to do that. As adults, we've developed all sorts of neural pathways, neural habits that allow us to drive a car, ride a bike, navigate a city, come to a conference. What an amazing thing. We get on planes, we come to a conference, we get here we are. A child could not do this. But we give up something. It's a trade-off. For being able to navigate our way to KataCon, we give up that open, exploring mind. We now are functioning more based on these neural pathways that get us through the day. I prefer having this rather safe than sorry mechanism than not, right? I don't want to shut it off, you know. It's a great mechanism to have, but it causes problems. We feel certain we make faulty decisions. If you read the top line, what does it say? Isn't it cool? You can't even see the total letters, but you can read it. That helps you get through life. But if you look down below, so a countermeasure to that neural mechanism that we have is scientific thinking. And I like this definition of scientific thinking. You heard it last year, for those of you who are here. A routine of intentional coordination between what we predict will happen, seeing what actually happens, and adjusting based on the difference. It's actually just that simple. We make a prediction, then reality happens, and if there's a difference, we learn from that. And I think that diagram captures it very well. There's nothing mysterious about scientific thinking. It's just not our natural way of working. Let's try it. Let's try it. Some of you know this one too. I like this little exercise. What will be the next number in this series? 2, 4, 6, 8, 10, 12. What will be the next number in this series? Please take a few minutes. Just kidding. Write down your prediction. Write down what will be the next number in this series. 2, 4, 6, 8, 10, 12. So the next number in this particular series is 2. Now, we don't have 5 question cards in our lanyard packs, but I happen to have a 5 question card here. And if you have one, let's flip it over and go on to the back of the card. What did you expect? 14. Okay. What actually happened? 2. What did we learn? Not a whole lot yet, right? We know it's not 14, right? That is 2. I heard a theory coming from over here. Maybe it repeats. Okay. All right. So we just reflected on an experiment. We did an experiment. We made a prediction. The prediction was refuted. We learned a little bit. So notice that we're learning via prediction error. What if it had been 14? What would that do? Gives us more data, confirms something we already thought. So it's starting to solidify our idea that it goes up by 2s, right? That's useful. But if it's different, we really learn something. Oh my gosh, prediction error is actually quite useful. All right, what theory did we have in mind? What theory were we testing? Goes up by 2s. That's a theory, all right? That theory has just been kind of shot out of the water. What theory would you like to test next? The pattern repeats after 12. Okay. So our next experiment might be to predict that we're going to see a 4. Okay. What if we ran this experiment 100 times and it always repeated after 12? Would we be certain? Or is it possible that at the 101st time a different number will appear there? It's certainly possible. It's certainly possible. Isn't that interesting? You're never certain. The scientist is never certain. It's actually a great way to go through life. It really is. You, instead of letting your brain be so certain that line continues, which maybe it does, maybe it doesn't, you try it. If you're going to experiment, and we learn from prediction error, we learn a lot from prediction error. We're not really adverse to prediction error. But if we know we're going to have prediction error, what should we do? How should we do our experiments? How should we design them? Keep the blast radius small, right? Don't design your experiments. How many times in the lean world, I don't know, how many people are sort of in the lean world or have lean backgrounds? Yeah, me too. How many times did we implement something, right? And when you start to do Improvement Kata, Coaching Kata, you realize the folly of that we don't know. Implement it on a small scale. Test it, because you're going to have to adjust it. Keep the blast radius small, because it may not be a 14 that comes up next. So, essentially, that 12 is the threshold of knowledge. We know it's 2, 4, 6, 8, 10, 12, but we don't actually know what's coming next. We predict it's going to be a 14, turns out it's a 2. Now we're going to predict after that, it always repeats after the 12, but we're never 100% sure. That's the threshold of knowledge. That's the threshold of knowledge that our brain tends to jump over and we don't see it. But the interesting thing is the threshold of knowledge is where the next experiment should be. And if you practice Improvement Kata, you get much, much better at seeing the threshold of knowledge. You discover they're all around you. And at first it's kind of disconcerting. You're like, oh my gosh, all this stuff that I was so sure about isn't actually necessarily true. But shortly after that, you start to go, this is so cool. I know exactly what to test. I know exactly where to test. I know exactly how to do the test. I know how to set it up so it doesn't hurt anything. And it becomes a very interesting approach. And you will have managers and you will have leaders who go, oh, experimenting. Boy, that's going to be slow. Toyota's faster than us. They learn faster. So actually doing small experiments with a limited blast radius and doing them quickly moves you forward faster. It's actually a little secret. It's kind of cool. So here's the thing. Oh, and don't feel bad about prediction error. It's a good thing as long as the blast radius was small. Here's the thing. Scientific thinking is learned. That's just the way it is, because as adults we have all these neural paths that we've built up from our experiences, the ones that allow us to drive a car, navigate a city, get to Katacon. How amazing is that we can do all that? We have all those neural paths, but because of that, our brain jumps to lots of conclusions all the time. So for adults, scientific thinking is learned. Okay, how do you learn it? So hopefully you're seeing that just talking about experimentation, just talking about iteration, just talking about scientific thinking, just talking about a lean kind of thinking or an improvement kind of thinking, even though it may be correct, doesn't change a thing. How do we develop new skills and mindset? Well, what does it take? So you know this one. Go ahead and fold your arms. All right, thank you very much. All right, and you know what's coming next. Please fold your arms or cross your arms the other way. Okay, I'm still not good at it. You'd think I'd get good at it. I only do it once a year. That's not enough practice, right? It's true. Okay, so you know the question is coming. How did it feel the second time compared to the first? Awkward. The first time was the right way. Yep. We're going back to the old way of doing a thing. Damn it. Yes. Conference is over. We're done. The key point has been made. What else? How does it feel? Unnatural. We had one yesterday. Forced, right? That was kind of good. All these words just sound like a the employee response to a lean implementation program, don't they? For a very good reason, right? So here are some words that other groups have used: awkward, slow, unnatural, stiff, uncomfortable. Had to think about it. I liked forced from yesterday. That was good. What the heck's going on here? What's going on? And by the way, this is just a small change. This is just folding your arms a different way. This is not culture change, which is what everybody's talking about these days. All right? We're talking about something pretty small here. What's going on? Well, we've been practicing folding our arms for decades. We have a super highway in our brain for how to fold our arms, how to cross our arms. Or as neuroscientists like to say at the bottom of the slide, every time you think or do something, you're more likely to do it again. Each time you do something, you're laying down a little more neural pathway, a little more highway for that particular way of doing something. And that puts us into kind of a self-perpetuating loop. Your behavior creates a mindset or pathways or highways in your brain, which of course drives your behavior. And pretty soon you are in this loop. That's just the way you do things. And it seems completely natural and normal to you. The second time feels different because we're using different neural paths. We're using neural paths that don't transmit energy very well. So our strong synapses, shown on the left in the slide, those are our practiced routines, our practiced ways of doing things, our practiced ways of thinking. Those superhighways in our brain take very little energy. The synapse on the left is folding your arms the way you always do, crossing your arms the way you always do. The synapse or neural pathway on the right is folding your arms the other way. It takes a lot of energy to get that signal through there, slows things way down, and it results in those words you said. I had to think about it, awkward, unnatural, forced. Takes a lot of energy. So that's what we think is going on in our brain. Here's kind of the message, taking it back from brain science to our world. You can't win fighting those neurons. You cannot win that game. whatever they're lecturing about up there is probably 100% correct. This is what Toyota does. This is how Kanban works. This is, that's all correct. You should think more scientifically. Scientific thinking is this. It's an intentional comparison between what we predict will happen and what actually happens and learning from and adjusting from the difference. It's true. But that by itself is not going to win. What's going to win is those highways in your brain. Trying to fight existing neural highways usually doesn't work. The learner, and I've made this sentence in red because this should sound familiar to anyone who's been part of a change program. The learner will almost always automatically stick with or revert back to their old way of doing things. And not because they're bad, but it's physiological. Because we're fighting those highways. I think Lean in the last 20 years has been about workshops. And I think our idea in the Lean world was, this is so cool, this is so good, once people see it, they're going to want to do this. And it didn't pan out that way. Just showing people a better way doesn't change it. We don't act a certain way because we lack information. We do so because it's a habit. So here's the strategy that we're pursuing with Kata. Don't try to fight those existing neural highways. You can't win that game. Build new ones. And over time, they will replace the highways in your brain. Create new highways. Let the other highways fade a little bit. I don't think we're ever going to be perfect scientific thinkers, but if we practice that scientific thinking, that will get stronger in our brain, and we will catch ourselves. We'll go, oh, wait, before we implement that big, why don't we test that? Or you'll be in a meeting, and you'll catch yourself saying, this is what will happen. By the way, if you become a scientific thinker, the word will disappears from your language. It just disappears. You'll catch yourself saying, this will happen. You'll go, oh, I don't actually know that. I predict, I think, I hope, I believe. Those are all good words because we can't predict the future. So grow new thinking, and that eventually replaces the old thinking. That's what we're about here. So what is happening is, here's that perpetuating, self-perpetuating loop, and this is where kata come in. And I don't call them kata anymore because it gets misunderstood as like a problem-solving method or something you implement. I call them starter kata. Starter kata are small routines you inject at the beginning of your practice to change your behavior a little bit, to start to change your mindset a little bit, to change your behavior, and it goes in a cycle. That's what starter kata are, and that's what we're trying to do. We're trying to do that for scientific thinking. I mean, you can do that for playing the piano or a sport too. Notice, of course, it's not just the repetition. This is what I had to learn as an engineer. I thought if you just repeat something over and over again, you'll start to learn it and you'll change your mind. You have to practice the right pattern. And when you practice, you're going to tend to use which neural pathways? The baby ones you've hardly ever used before, or that superhighway? Which one are you going to use when you practice? You're just going to slip back into that. You won't even notice it. So that means you need a coach. Because the coach will stand there and say, you're doing that a little bit wrong. Let's correct that right away, because as you know, the statement, it's not practice makes perfect. Perfect practice makes perfect. The coach is there to make sure you practice the new ways that are still unnatural to you at the beginning. That's what coaching is about. The other thing is your emotions play a big role. And this is something that coaches have to be aware of. And those of you who coach other people, Michael, I know you know this, if someone's practicing but they're not into it, they're like, why am I doing this? It's kata stuff, flavor of the month, another lean thing, that kind of thing. And they practice, they can go over and over and over the routine. They won't learn it. You have to have a positive emotion. Periodically during their practice, the learner has to experience some positive feelings about what they're doing. Hey, I'm getting better at this. Their self-efficacy needs to go up a little bit. And it's really kind of the coach's job to make sure that happens. So it's not just, hey, if you repeat this, just do your reps and you'll get it. If you do reps with muscles, they'll grow. But your brain's a little different. So the cool thing is we have starter kata for each step of the improvement kata pattern. And that comes from a recognition that you can't just share a model with people and hope that that's going to change anything. So they're actually starter routines for each step of the improvement kata pattern. And that's what I was talking about in the Kata Geek meetup. People are starting with those starter kata and then taking it in whatever direction they want. It's simply a starting point. Why not start with those? There's also a coaching kata because we recognize you need someone to kind of correct your practice so that you practice the right thing at the beginning anyway. But Michael, I think you're right. Have a coach, be a coach. When you start to coach someone else is when you really start to learn. So as soon as you can, start coaching someone else and you'll discover amazing things about yourself. Here, this is a Homer Simpson dope slap moment. You know that feeling you were describing, right? When you folded your arms the other way? Awkward, forced, right? Slow, unnatural, have to think about it, stiff, uncomfortable. These are all words used to describe that. Here's the deal. That's exactly what you want to feel. And in the past, with lean efforts, we go, yeah, I know it's uncomfortable, I'm sorry, change hurts and that kind of thing. Now it's like, oh, you're feeling those things? Awesome. What that means is you are writing new neural pathways. You're starting to lay down some new tracks, and it's going to feel that way. And if you don't feel that, you're not learning. If you don't feel that, you're probably exercising existing neural paths. So isn't it funny that those negative words that we use are actually what we want to be feeling? They're a sign that we're doing the right thing. So here's a coach and learner in a coaching cycle. They're all happy, smiling. I like to pick pictures where everybody's happy doing kata. Maybe I should stop doing that. Here's a picture of a coach and learner punching each other, right? Wow, they're learning, man. I want to go benchmark that company, So they're smiling, but she's practicing. The woman on the right, she's the learner. She's using like the experimenting record, which is a starter kata, which you can then evolve into whatever you want, as long as the basic pattern of the starter kata remains. And she's using that, and it's awkward. How many times has someone, if those of you who've done kata practice, has someone said, why am I doing this? This doesn't feel right. Why can't I just implement it? Why can't I just say this? Why do I have to fill in what I think will happen? What's the difference between what happened and what I learned? Why are there two different columns there? And you see the little crossed arms, angry guy, right? So the learner is actually feeling that, as they should be. That means we're on the right path. And the same thing for the coach. Here's the coach using the 5 coaching kata questions, which are just the headings for the coaching cycle. You can ask other questions in between. How many times, for those of you who do this, has a coach gone, they start to go off the card immediately, and you go, hold on, it's a starter kata. For the first 10, 15, 20 times, I want you to just read the card. Oh man, I don't want to read the card. And then they keep deviating and you keep bringing them back in just to practice the starter kata. Not forever, just at the beginning, right? And they're like the little guy with the folded arms in the left-hand corner, right? Well, now you know. That's exactly what should be happening. You want them to go, I don't like this. This feels unnatural. Awesome, we're on the right track. Keep going. We're not going to be very popular. And then here is a wonderful 5-question card. On the left are the 5 questions, but it's a folding card. And on the right is a blank space where this particular coach is writing in the questions they like to ask in between the heading questions of the coaching cycle. And what's happening is they're going beyond the formal kata, but beyond the starter kata, and developing their own way. This is what we were talking about the MEP at the Kata Geek meetup yesterday. That's what we want to see. The starter kata pattern remains, but the learner moves on and develops their own way that works in their particular industry. We have several industries here that works in their particular company, their organization, or just works for them. But the pattern is in there. All right, so knowing isn't the same as doing. Benchmarking is not enough to make change happen. Scientific thinking is a good way to navigate, but it's not our default mode. You kind of have to practice it. Skills, habits, and mindset are wired in our brain, and you can practice starter kata with some coaching and positive emotions to help wire your brain for scientific thinking. And we believe, and I think this is a theory at this point, and that's what the Toyota Kata Culture book is about, we think you can also modify an organization's culture this way over time. Best wishes for your practice, and best wishes for an interesting 2 days.